Hello and welcome to Lapping Analytics. My name is Jimmy Lapping. I'm a psychologist and statistician with an interest in a variety of topics that are commonly studied in the health and the social sciences. And in this video, I'm going to talk about qualitative comparative analysis. And I'm going to do that with a hypothetical example of a study that tries to investigate the question how people feel about the rise of artificial intelligence, in short, AI. Suppose we ask participants in this study to individually and independently, that is, without consulting others, respond to this question by choosing the category out of the following four options that describes best how they feel. And the options are indifferent, curious, fearful, or optimistic. Suppose that we treat these four options as mutually exclusive options and therefore ask the individual participant to choose one of these options. From a methodological perspective, one of the questions that arises at this point is what kind of variable this is. It is not a continuous or otherwise quantitative outcome because any quantities assigned to these emotions will be arbitrary and most probably meaningless. And it is not an ordinal variable either because we cannot rank these four options in a non-arbitrary manner in the sense that one is always more or better than the others. This variable, feeling, with its four possible options, is probably best described as a multi-category nominal outcome variable with four distinguishable categories. But it is unclear, for example, whether curious is between fearful and indifferent, or between indifferent and optimistic, or both may be the case and it is just a matter of who you ask. And apart from this question on the nature of the feelings variable, in this kind of studies we typically have an interest in how this variable can be explained by a few other variables that we can document. For example, do people who work in healthcare or finance or education or technology tend to provide different answers to this question of how they feel about the rise of AI? Or do people who have a bachelor's degree in some field or even a master's degree or a PhD or any other kind of degree, for instance a professional degree, respond differently to this question? Both the field and the degree variable may best be characterized as multi-category nominal variables as well. For the fields, there is certainly no way to just rank order them in terms of good, better, and best. And for the degrees, although some may argue that bachelor's, master's, and PhD can be ordered in that fashion, not everyone will agree with that because this kind of ordering is to some extent a matter of perspective, and besides, the category of other degrees can mean a lot of things and may not necessarily be ranked as worse or better than or inferior or superior to other categories here. Besides, it is well possible that people hold several degrees, complicating good, better, best rank order exercises even more. So, for the ease of the example, let's suppose that we ask this question, how do you feel about the rise of AI, to a total of 48 people, each of whom choose one of four possible feelings, may choose one or several fields in which they work, because there are people who are professionally active in, well, something that could be, that is captured by two fields, for instance, or maybe three even. but they will choose the degree option that best fits with them. So for instance, if someone has a bachelor's, master's and a PhD, that person will respond PhD. That's the last degree they got in this case. So let's have a look at the data. Again, these are not real data, just simulated data, because the example of this video is about a hypothetical and not a real study. Suppose that of the 48 people we ask, 12 respond that they feel indifferent about the rise of AI. Of these 12 people, only 3 hold a degree that can be classified as bachelor's, master's or PhD. 4 are currently professionally inactive. 1 works in education and technology, and the others work in a field that cannot be characterized as healthcare, finance, education, or technology. Another 10 participants responded that they feel curious, indicating that they have an interest in learning more about AI and its possibilities. We see nearly all of them have a bachelor's, master's, or PhD degree, and all of them work in a two-field combination of education, technology, healthcare, and finance. Next, the largest group, a total of 19 participants, responded fearful. All of them are professionally active, and just over half of them have a bachelor's, master's, or PhD degree. And the remaining 7 participants, the smallest group in this sample, responded that they are optimistic about the rise of AI. Again, as for curious, nearly all of the participants who responded that they are optimistic about the rise of AI have a bachelor's, master's, or PhD degree, and all of them work in at least one of the 4 defined fields of healthcare, education, technology, and finance. On the degree side, we see that especially the PhD category is very low in frequency, yet on the professional side, we see that all currently inactive participants endorse the indifferent option, and the majority of people not working in any of healthcare, education, technology, and finance, which are, so those are the people who are characterized as other in the professional field, also endorse the indifferent option. The vast majority of the professionally other participants endorse the indifferent option. Now, if we want to understand to what extent degree and professional field can explain participants' response to their feeling about the rise of AI, a first family of statistical tools coming to mind may be that of regression analysis. In addition, given that the outcome variable of interest, that of feelings, can be understood as a multi-category nominal variable, the type of regression analysis that comes to mind is probably that of multinomial logistic regression. However, with this kind of sample size, that approach is simply not feasible. Some combinations have 0 or near 0 frequencies, and there is simply too little information in the data for multinomial logistic regression to be a reasonable option. And this is where qualitative comparative analysis comes in. If you want to know more about qualitative comparative analysis, there are good tutorial articles and videos that are freely available on the internet. And if you look in the recent history of videos on my channel, you will find a few videos on this configurational method as well. Now, when you go through the tutorials on the internet, you will probably find that all examples focus on outcome variables that are either quantitative, ordinal, or dichotomous. Yet here we have a multi-category nominal outcome variable. So how can we deal with that? Well, the most straightforward manner is to conduct qualitative comparative analysis for each category of the outcome variable, and that is what I will show in this final part of the video. starting with indifferent. For indifferent, we find that first of all, there are people who are professionally inactive, the first row in the table. We just saw that all 4 participants who are currently professionally inactive endorse the indifferent option, and this explains why the consistency is 1, indicating 100% or perfect consistency. That is, every time we observe a participant who is professionally inactive in this sample, that participant responds indifferent to the question on how they feel about the rise on AI. And the raw coverage of inactive is 0.333 because of the 12 participants who endorsed the indifferent option, only 4, hence 1/3, are professionally inactive. In other words, the perfect consistency indicates that in our sample there are no exceptions to the rule, but that the rule of being professionally inactive only covers 1/3 of the cases in which a participant endorsed the indifferent option. Next, people who have neither a bachelor's nor a master's degree and work in a field that is not healthcare, education, finance, or technology also tend to endorse the indifferent option. And the solution as a whole has a consistency of 0.909 and a coverage of 0.833. For consistency, values above zero point 0.8 are generally considered good, and coverage values starting 0.75 are generally also considered good. In other words, for the indifferent option, we have a solution that is consistent and covers most of the cases, to be exact 10 out of 12 of the participants who endorsed that indifferent option. Next, curious. Here we find a solution that comprises 2 rules with a consistency of 1 and therefore has an overall consistency of 1 as well. The first rule is working in healthcare but neither in finance nor in education. And the second rule is working with a bachelor's degree in technology but not in finance. The coverage of this solution is 50%, hence 0.5, because of the 10 participants who endorsed the curious option, only 5 are covered by this solution. In other words, while we have a perfectly consistent solution, it covers only half of the observed curious participants. Next, the largest group, fearful. Here we see a somewhat more complex configuration of rules, which you can figure out for yourself based on my explanations thus far, when putting this video on pause, for example. And this solution also has a perfect consistency, but covers only just about 63% of the observed fearful cases, to be exact 12 out of 19 cases. And finally, for optimistic, we find a solution that in terms of complexity is somewhat in between the previous options, is perfectly consistent, and covers 4 out of the 7 optimistic cases, hence a coverage of about 57%. What these numbers mean must, in a real study, be interpreted in the context of the study, and studies in other settings may help to investigate the generalizability or transferability of findings from the study at hand to other settings. But this is in a nutshell how qualitative comparative analysis works. No standard errors, confidence intervals, or p-values like in statistical methods, which are based on assumptions that for the dataset at hand are unrealistic, but through combinations of consistency and coverage can provide somewhat of a better understanding of the potential of different solutions. Having said, that's it. I hope you find this video useful. If you have any questions or suggestions, just leave a comment below the video. And on my channel, you will find plenty more videos related to methods for qualitative, quantitative, and mixed methods research. Thank you for watching. Thank you for listening. And I hope to see you back on this channel soon.